Okay, so in this video I'm going to have a look at the first two questions in Paper 1 Higher Level Maths 2016. So this is question 1 here. It just says that this part A here, minus 4 plus 3i is one of the roots of the equation az squared plus bz plus c equal to 0. A, b and c are real and I squared is minus 1. And we just have to write down the other root. Now this is just basically the conjugate root theorem. So we're told that the coefficients here and c, they're all real, so therefore we can use the conjugate root theorem. So the other root here is just simply the conjugate of minus 4 plus 3i, so that's minus 4 minus 3i is the other root. Okay, so that's fairly straightforward. Now the next question here, we just have to use de Moivre's theorem to express 1 plus I to the power of 8 in its simplest form. So let's have a look through that one. Okay, so if we look at 1 plus I to the power of 8, well, just 1 plus I, first of all, if we just draw a quick sketch of that, it'll look something like this here. So that's your 1 plus I. So we can see here that because we've got a 1 here and the coefficient of this I here is also 1, we know that this angle here, our theta, our argument if you like, is going to be 45 degrees or pi over 4. Now you can do that, you can say tan theta is equal to 1 over 1 or just 1, so theta then is just going to be tan inverse of 1, so theta is just going to be 45 degrees, or we'll use radians, so it's going to be pi over 4 here. Now we also need the modulus, or this distance here. We're going to convert this, by the way, to polar form. That's what we're doing here. So this distance here, we can see if that's 1, that's 1. This distance here is going to be the square root of 2. So in other words, the square root of a squared plus b squared, which is the square root of 1 squared plus 1 squared. So that's just simply, that's going to be our or if you like. So that's, our or is just going to be root 2. So converting this to polar form, we get root 2. So in other words, 1 plus I, let's say to the power of 8, we'll stick to the whole thing here, is just going to be the square root of 2. That's our or. Cos theta, so that's going to be cos pi over 4 plus I sine theta, sine pi over 4, and remember we're raising all of this as well to the power of 8. Okay, so let's just do this. Now this is where we use de Moivre's theorem here. So we're going to raise root 2 to the power of 8, so root 2 to the power of 8 is just going to be 16. Let me just double check that. So it's going to be root 2 times root 2, so that just gives me 2. And we're going to do that 4 times, so 2 2 is 4, 4 is 8. Yeah, so that's just going to give us 16. That's fine. Okay, so here now is where we're going to just bring the 8 down in front of the angle here. So it's going to be 8 times pi over 4, or just simply cos 2 pi. Plus I sine 8 times pi over 4, or sine 2 pi. Okay, so that's really it, but it says in its simplest form. So let's see what we can do with this. The cos of 2 pi, or the cos of 0 if you like, is just going to be 1, plus I, the sine of 2 pi, the sine of 0 degrees if you like, or the sine of 360 degrees, is just going to be 0. So we just simply end up with 16 times 1, which is 16. Okay, and that's it for part B, so let's move on. Okay, we have another one here. This is part C. This is 1 plus I is the root of this equation here. Find the other root. So this is similar to the other one, however, we can't use the conjugate root theorem in this case because our coefficient of the z here is not real. So we're going to have to find some other way of doing it. Now normally what you do here is if 1 plus I is the root, then z minus 1 plus I is a factor, so we can divide that in, and that's the way I'm going to do it here. just going to take z. I'm going to take z minus this 1 plus I, and I'm going to divide it into z squared plus minus 2 plus I times z plus 3 minus I. And so I should end up with another factor up here, and from that then I should be able to get my root from that. So let's do that. So you divide the z into z squared here, and you get z, so multiply the z by all of this here, and you'll get z squared. Then you'll get minus 1 plus I times z. Okay, so we put a line under this then, and usually what we do then is we subtract all of this here. So let's do that. So this will we'll get 0 here, it'll cancel if you like, and when we add these two, because you're going to change, this is going to change to a plus here, so we're going to add these two here, and what you end up with is let's see, 1 minus 2, so that's going to give me minus 1, and then I'll end up with plus 2i, and that's all times z. I'm going to bring both of these down here now, so I'm going to bring down the plus 3 and the minus I and start all over again. So divide z into our first term here, and I just end up with plus minus 1 plus 2i. And this looks like our factor up here. I presume when I multiply with this by this, I should end up with this here. Because I can't do it, there's no more terms here I can bring down. So let's do that. So I'll end up anyway with minus 1 plus 2i times z here. And I know that if I multiply this here by this here, first of all it's plus times minus, so I'll get a minus here. And then when I multiply this by this here, you can do it separately yourselves, but I'll end up with minus 3 plus I. And you can see here that again, if I subtract all of this here, subtract that, that will cancel here if you like. This here will become plus, and this will become minus. So minus times minus is plus, so I'll end up with plus 3 here. This will make it minus, and this will cancel again, will give me 0. This minus times plus will give me a minus here, and this minus times this minus will give me plus, so this will cancel here then. So I'll end up with 0 down here. So this here anyway is my my other factor. So let's have a look at that. Okay, so we know that z plus minus 1 plus 2i is a factor, so that means z is equal to minus 1 minus 1 plus 2i is going to be a root. This is my factor here, so this must be my root here. So that means z then, my other factor, my other root rather, is going to be 1 minus 2i. 1 minus 2i. Now you can check that as well by putting it into the original equation here, and I've done that separately, and you do actually get 0. So you can put 1 minus 2i in here instead of z, 1 minus 2i here instead of this z here, multiply it all out, and you do actually get 0. Okay, so this is my answer here, this is my other root. Okay, so that's part C. Let's move on to question 2. Okay, question 2 then is finding the range of values of x for which the modulus of x minus 4 is greater than or equal to 2 and x is real. Okay, so let's just write that down again here. We have x minus 4, the modulus of x minus 4, and that's greater than or equal to 2. Okay, so the way I'm going to do this, a couple of ways of doing this, but the way I usually do this is square both sides. So I'm going to take the x minus 4 and I'm going to square it, and I'm going to take the 2 and I'm going to square it to give me 4. So this just guarantees that everything on both sides is positive. And you can take away the modulus symbols then as well. Okay, so let's multiply this out. Here we get x squared minus 4x minus 4x, that's minus 8x, and then plus 16 greater than or equal to 4. So that gives me x squared minus 8x. I can bring this 4 over here if you like, and subtract 4 from both sides, and that gives me plus 12 greater than or equal to 0. So this here is what we really want to solve. So the first thing we normally do is just let it equal to 0. So we take x squared minus 8x plus 12 here equal to 0. Okay, so the reason we do this is because we want to find the roots of this equation. We want to find where this cuts the x-axis. So let's just solve this. So we get x equal to 0. It's 12, so it's going to be, let's say, 6 and 2. Anyway, 6 and 2. This is plus here, and we've got a minus here, so there's going to be 2 minuses here. So that gives us x is equal to 6 or 2. 6 or 2. So our graph will look something like this. Okay, so these are our two roots here, one here and one here. Now we weren't asked to solve for this here being equal to 0. We want to solve this here. This is what we want to solve. So we want our function here to be greater than or equal to 0. In other words, we want this part of the graph here. And it's equal to 0 as well, so it includes this point here. And we also want this part here, so we want this point here as well. So what x values give us those particular y values? Well, we're going to be looking at all of these x values down here and all of these x values up along here. So let's just write that out. So what's our solution then? Our solution then is going to be x greater than or equal to, remember this is 6 here and this is 2 here, x is equal to 6, x is equal to 2. So we want x greater than 6 and we want x greater than or equal to 6 I should say, and less than or equal to 2. So there's our solution there. And that's it really, that's part A. Let's have a look at part B. We have to solve these simultaneous equations, okay, or solve these equations simultaneously. So let's have a look. Normally what we got here is we got one equation here with an x squared and a y squared in it. Down here we've got this linear equation. So usually what you do then is you would take the linear one, x plus 3y is equal to minus 1, and you would take the x or the y, whichever you like, and just express it in terms of the other variables. So what I'm going to do is take the x and express it in terms of y. So let's do that. So that will give me, let's see, 2x is equal to minus 3y minus 1. That will give me x is equal to minus 3 over 2 y minus 1 over 2. X is equal to minus 3 over 2 y minus 1 over 2. Okay, so that's what I'm going to use for x in the other equation. So I'm going to take x out of the first equation and put this in instead. So then I'll have an equation with only y's in it. So let's do that. Okay, so what's the other equation? Let's see. Well, we have x squared anyway, so it's going to be minus 3 over 2y minus a half. That's my x. That's this part here. We're going to square that. Plus, then I'm going to write the x down again and multiply it by y, so it's going to be minus 3 over 2 y minus a half times y, and then plus 2y squared, and that's all equal to 4. Okay, I think I have that right, so, whoops, sorry, let's solve this then. So we have an equation here, and the equation just has one variable now. It has a variable y in it, so we can solve that. So let's do that. Now, you just got to multiply this out carefully. The numbers are a little bit awkward, but you just got to multiply it out carefully. So let's see. To multiply all of this out here, we're going to end up with 9 over 4y squared plus 6 over 4y plus 1/4. Now we've got to multiply this out here, so we're going to end up with minus 3 over 2y squared and minus half y, and then we've got this plus 2y squared here. All that's equal to 4. Okay, at this stage we just look at, we've taken away the brackets here, we multiplied everything out, but I have all these fractions which I don't like, so I'm going to get rid of those fractions. So I have, my denominators are 4 and 2, so that's handy enough. I'm just going to multiply across by 4. So I'm going to end up with 9y squared plus 6y plus 1. Now, multiplying this by 4, that will give me 2 on the top times 3, so that will give me minus 6y squared. Here again I'll end up with 2 times 1 on the top, so that's just 2y. Multiply this by 4, that will give me 8y squared. And on the right hand side, for 4 is 16. Very often I find students will forget, and I do it myself the odd time, just forget to multiply the right hand side as well, but you've got to do both sides, of course. Okay, so now let's just see if we can simplify all of this. Now let's see. When you simplify all of this, what you end up with is 11y squared plus 4y minus 15 equal to 0. You'll find you can factorize this reasonably easy. If you can't, you can always use the minus b formula, but it does work out. Let's see, we've got 11y times y, and then we've got 15 times 1. You can probably spot anyway that 15 minus 11 will give me 4 anyway. So we want plus times minus, so the larger one here has to be plus, and this is minus here. That gives us a y value, or two y values rather, of minus 15 over 11, or we also end up with 1. Okay, so let's work our way through these two now to find our 2x values. Okay, so let's do that. Now I'm running out of room here, but that's okay, we should fit it in. Let's see. Let's take y is equal to minus 15 over 11 first. We'll do that one first. So you got to stick this into the original, one of the original equations anyway. So we'll pick the linear one, it's usually the easier one to do. So let's do that. So we have 2x plus 3y, and that's equal to minus 1. So we got to put our y in here, so that will give us 2x plus 3 times minus 15 over 11 equal to minus 1. So that will give us 2x minus 3 15s 45 over 11 is equal to minus 1, and then we end up with 2x equal to 22x. Actually, what I can do here is multiply across by 11. That will give me 22 here. Let's see, I can multiply across by 11, that will give me 22, and let me actually just go back a little bit here. Let's just multiply across by 11 first. Okay, so 2 times 11, 22x. This will give me 45, and over here then I'll end up with minus 22. Okay, so let's see what happens here. Sorry, that's not minus 22, that's minus, what am I multiplying by? 11, so 11 has to 22, 11 minus 11 here. Okay, so let's see what happens. So I end up with 22x is equal to minus 11 and plus 45, so that'll give me 34 here. So here I'll end up with x is equal to 34, 34 divided by 22, so that'll give me 17 over 11. Okay, so now what about y is equal to 1? So let's do that one then. Y is equal to 1. So again we'll use the same equation. 2x plus 3y is equal to minus 1. So we're going to put in 1 for y, so we get 2x plus 3 times 1. is equal to minus 1. That will give me 2x. 2x here. Plus 3 is equal to minus 1. That will give me 2x is equal to minus 4. That will give me x is equal to minus 2. Okay, so there are all my x's and y's. So let's see, what did I end up with? Just write them down here. X is 17 over 11 and y is minus 15 over 11. And the other one here is x is minus 2 and y is 1. Okay, so there are my solutions to those simultaneous equations. So I'll do the other questions, another 2 or 3 questions in the next video. You can have a look at those.